Okay, good evening students. So welcome you all for the evening classes. So today we got little bit problem with our power. So that's why I was not able to take the class in the evening at 6 p.m. So no problem. Now we can take the class. Okay. So give me some few minutes so that I will share the link that I have. So good evening to everyone. Okay. So hi, Jayed, Muttappa, Shivu and Bhagyavant. So welcome to the class. So class is live now. So who all want, they can attend the class. No problem. Okay. So I have shared the link also for your friends. So give me some 2 minutes of time. Okay. So now we can start the class. Okay. So hello and hi. Welcome you all for the evening class. So the afternoon class, sorry, in the evening 6 o'clock, I scheduled one class for your relations and functions. So I will see after this class, we can continue that problems. And if I get the time, I will continue today only. Otherwise, we can go for tomorrow. Okay. So we can cover it tomorrow. Otherwise, today only I will take those classes. Let us see what will happen. If time is there, today only we can continue. Otherwise, we can continue tomorrow. No problem. Give me some 2 minutes of time. I will check the file and I will take it. This is our o'clock file. Okay, no problem. We can continue this relations and functions, which is scheduled for 6 p.m. So after that, we can go for our differentiation chapter. No problem. So I will continue with our 6 p.m. class that was scheduled for 6 p.m. So I will continue it. I will continue with it. So we can differentiation chapter. Okay. So let us go through it. See the ninth problem. That is so quickly reply me everyone. Good evening to everyone. Are you ready for the class? So I will take relations and functions. So I will check that file where is it, and afterwards we can go for our differentiation topic. Okay. So I will continue with our different functions topic, and later we can continue with our differentiation chapter. Clear? Okay. See this. Solution of ninth problem, that is f is from r star to r star and it is defined by f of x equal to 1 by x, and it is defined by f of x equal to 1 by x, and you can see here r star is non-zero real number set, non-zero real number set. So why they are telling it as non-zero real number set? Because if 0 present in R, if 0 present in R, 1 by 0 will be not defined, will be not defined. So because of this condition, what they are telling, R star, which is a non-zero real number set. That means R star is nothing but it is not with 0. 0 is not present in this real number set. 0 is not present in this real number set. So therefore, from that condition, they are going to use it. Clear? So therefore, this will be equal to R star. Okay. So therefore, now you can see we have to show that it is both 1 1 and onto. 1 1 and onto. So links I will send later, don't worry. Links I will send later. Don't worry about it. So we can go through this class now. So laterly we can go through our differentiation topic. Okay. So don't worry about that. I will take that also. This was scheduled at 6 p.m. but at 6 p.m. because of power cut problem we have not taken that class. So that I will continue here. So tomorrow or after the end of this session we shall see if time is there we can continue. Clear? Okay. So 1 1. What is your function? F of x. So f of x1 will be equal to what? 1 by x1. F of x2 will be equal to what? 1 by x2. Okay. So therefore consider f of x1 equal to f of x2. Consider f of x1 equal to f of x2, that is what? 1 by x1 equal to 1 by x2. Cross multiply the terms. X1 will be equal to x2. So it is 1 1 function. You can say that it is 1 1 function. Okay. Now go for onto. So how to show that it is onto? Consider f of x equal to y. Consider f of x equal to y. That is nothing but y will be equal to 1 by x. And x will be equal to what? 1 by y. Where y belongs to R star. That is non-zero real number set. So therefore, for every y belongs to R star, there exist x belongs to R star such that f of x equal to 1 by x. Such that f of x equal to 1 by x. Therefore it is onto. Hence it is both 1 1 and onto. So that you can say it as bijective function also. Clear? So it is 1 1, it is onto. Therefore it is both 1 1 and onto. Hence you can say it as bijective function. Clear? This is very simple. No problem. Let us go for the 10th one. So see the 10th problem, that is, let A equal to R minus singleton set 3, B equal to R minus singleton set 1. Now f is a function from A to B. That is f of x equal to x minus 2 divided by x minus 3. X minus 2 equal to x minus 3. Okay. So now we have to show that f is 1 1 and onto. So for that I will take first it as 1 1. So how to show it as 1 1? You just see here. Take f of x1, that will be x1 minus 2 divided by x1 minus 3. Take f of x2, that will be x2 minus 2 divided by x2 minus 3. So consider f of x1 equal to f of x2. So from this what you are going to get, x1 minus 2 divided by x1 minus 3, that is equal to x2 minus 2 divided by x2 minus 3. So now you can make cross multiplication, that will be x1 into x2 minus 3x1 minus 2x2 plus 6. So that will be equal to x1 into x2 minus 2x1, and you can just see x2 into x1, and this will be x2 into minus 3 minus 3x2. So minus 2x1 plus 6. Clear? So therefore x1 into x2 will get cancel. You can take x1 terms one side, plus 6 will cancel. Take x1 terms on one side, that will be 3x2 minus 2x2 will be equal to 3x1 minus 2x1. So you rearrange the terms, that will be 3x2 minus 2x2, 3x1 minus 2x1. So therefore x2 will be equal to x1. Therefore it is 1 function. Therefore it is 1 function. Okay. So now we have to go for onto. No problem, you have to show that it is both 1 and onto. So that's why you can just take f of x1 as x1 minus 2 divided by x1 minus 3, f of x2 as x2 minus 2 divided by x2 minus 3, and you consider f of x1 equal to f of x2. From that you can take x1 minus 2 divided by x1 minus 3 equal to x2 minus 2 divided by x2 minus 3, make cross multiplication, and you just simplify, it will be 1 function. Okay. Next see onto function. So for onto function, what you have to do, consider f of x equal to y. So now what is y equal to? The given function is x minus 2 divided by x minus 3. Okay. So therefore make cross multiplication, xy minus 3y will be equal to x minus 2. So therefore here you can write it as xy minus x equal to 3y minus 2. You can take x term as common, y minus 1 equal to 3y minus 2. So therefore x will be equal to 3y minus 2 divided by y minus 1. So therefore for every y belongs to B, you can see for every y belongs to B, that is codomain, for every y belongs to B, that is codomain, there exist x belongs to A, that is domain such that f of x equal to x minus 2 divided by x minus 3. So hence it is onto. Okay. So therefore it is both 1 and onto, therefore it is bijective. Clear? So hence it is both 1 and onto, therefore it is bijective function. Okay. So quickly tell me, all of you, have you understood this problem? Problem number 9 and problem number 10. Problem number 9 and problem number 10, you can just go through it and you can understand them, no problem. Okay. So now I can go for problem number 11. Clear? I will go for problem number 11. And we can solve it, no problem. Okay. So you see this, that is problem number 11. Okay, what is problem number 11? You just see. Understand the problem first. That is, consider the identity function. From n to n. So consider the identity function from n to n defined by I n of x is equal to x. That is nothing but, here it is nothing but f of x is equal to x. Okay. For every x belongs to n. show that in is onto, show that in is onto, but in plus in, n goes to n, defined by in plus in of x. This is nothing but, again you can take it as f of x, that is equal to, see this, in plus in of x equal to x plus x is 2x. So f of x is equal to 2x. Clear? So that means you have to show that this is onto, but 2x is not onto. Clear? You have to show that f of x is equal to x is onto, but f of x is equal to 2x is not onto. You have to prove this. Okay, so no problem. First let us take onto. First let us take onto function. That is, I will take in of x is equal to f of x, that is nothing but x, for every x belongs to n. So this is given. Okay, so to show that onto, consider f of x is equal to y. Consider f of x is equal to y, that is nothing but y will be equal to x. Y will be equal to x. So you can write, for every y belongs to n, for every y belongs to n, there exist x belongs to n, x belongs to n, such that f of x is equal to x, that is equal to in of x. F of x is equal to x, that is in of x. Hence it is onto. Hence it is onto. Hence it is onto. Okay, so we have shown that it is onto. Clear? So proving that it is onto is very simple. Consider f of x is equal to y. We know that f of x is nothing but in of x. Therefore y is equal to x. For every y belongs to n means this is codomain. For every y belongs to n means this is codomain. For every y belongs to n means this is codomain. There exists x belongs to n, that means domain. Okay, so therefore this n belongs to y and this n belongs to x. So from that you can say in of x is equal to f of x, that is equal to x. It is onto. So next we shall show that it is not onto. So how to show that it is not onto? Very simple. You just see here, take f of x what? That is, to show that it is not onto, what you have to show? What they have given? They have given in of x plus in of x. So I will take this as g of x, which is equal to 2x. Okay, so if you write like this, range will be what? Range will be equal to 2, 4, 6, 8, so on. Multiples of 2 will be the range. But you can check what is codomain. You can check codomain is what? Codomain is, you can see here, natural number set. Codomain is natural number set. Okay, so therefore clearly range is not equal to codomain. Range is not equal to codomain. Hence it is not onto. Hence it is not onto. Okay, so from this you can tell it is not onto. So I think 11th problem has been clear to everyone. Very simple problem. Don't get confused with the length of the question. You just understand it. They have given two functions. One is f of x equal to x. Another one is f of x equal to 2x. So they are asking that f of x is equal to x is onto and f of x is equal to 2x is not onto. So for that we can easily prove it. No problem. We got our answer. Okay. So now let us go for the 12th problem. Let us go for the 12th problem. That is, so given that f is a function from R to R defined by f of x equal to mod x, defined by f of x equal to mod x, and you can see that they are asking to show that it is neither 1 1 nor onto. They are asking to show that the function f of x is equal to mod x is neither 1 1 nor onto. Okay, so let us prove it as neither 1 1 nor onto. So for not 1 1, what you can write, you just see, take x1 as 1, x2 as minus 1. So now what will be f of 1? Mod 1 equal to 1. What will be f of minus 1? That will be mod of minus 1. That will be plus 1. Therefore, f of 1 is equal to f of minus 1, but 1 is not equal to minus 1. Hence, or you can say it is not 1 1. It is not 1 1. Very simple. Okay. You take plus 1 and minus 1. If you take plus 1 and minus 1, f of 1 you can write it as 1. F of minus 1, that is mod of minus 1, will be also plus 1. So you see here f of 1 is equal to 1. F of minus 1 is equal to 1. Therefore, f of 1 equal to f of minus 1. But 1 is not equal to minus 1. Hence, it is not 1 1. Okay. For not onto. Not onto. How to show it is not onto function? Okay, so for not onto function you can write it as range will be equal to positive real numbers. Range will be is equal to positive real numbers. Positive real numbers. Positive real numbers. But what is codomain? Codomain is equal to real number set. Codomain is equal to real number set. Therefore, clearly range is not equal to codomain. Range is not equal to codomain. That is, it is not onto. It is not onto. Okay. Clear? So clearly you can see range will be positive real numbers because mod function tells about only positive real numbers. Therefore, codomain is real number set, hence range is not equal to codomain. Or you can also write it in another form as for not onto, you just see, for not onto you just see, you take f of x equal to y, y will be equal to mod x, y will be equal to mod x. So now what will be x equal to? X will be equal to what? Only you can see that mod x, if you want to simplify it, it has two terms. Y is equal to plus x or y is equal to minus x. Y is equal to plus x and y is equal to minus x. So for you can see here all positive real numbers are possible. For the second case, you can just say x is equal to minus y. X is equal to minus y, which is not possible. Which is not possible. Which is not possible. Therefore, it is not onto. Therefore, it is not onto. Okay. Clear? So like this also you can solve. Very simple thing is you write range is positive real number set, codomain is real number set. Therefore, range is not equal to codomain. This will be very simple. So you can follow this. Clear? So this is also correct, but it will take little bit more time. No need to go through this. Okay. Now let us go for 13th problem. Let us go for 13th problem. What is the 13th problem? Again, f from R to R. F from R to R defined by f of x is equal to greatest integer of x. F of x is equal to greatest integer of x. Hence here show that function f is neither 1 1 nor onto. So again they are asking to show that it is neither 1 1 nor onto. Okay. Let us show that it is neither 1 1 nor onto. So for f of 1.1, that will be greatest integer of 1.1. What is greatest integer of 1.1? All of you know that 1. You can take greatest integer of 1.3. That will be greatest integer of 1.3. That is nothing but again 1. Okay. So f of 1.1 is equal to f of 1.3, but 1.1 is not equal to 1.3. It is not 1 1. It is not 1 1. Okay. So clearly you can see that f of 1.1, that is greatest integer of 1.1 is 1. Greatest integer of 1.3 is also 1. But f of here f of 1.1 is equal to f of 1.3, but 1.1 is not equal to 1.3. Therefore it is not 1 1. Okay. So for not onto, you can just see range will be equal to integer set. Range is equal to integer set. But what is codomain? Codomain is equal to real number set. Codomain is equal to real number set, that you can see here. Okay. So therefore clearly range is not equal to codomain. Range is not equal to codomain. Therefore it is not onto. Therefore it is not onto. Okay. So it is neither 1 1 nor onto. It is neither 1 1 nor onto. Clear? So very simple functions that you can use and you can solve them, no problem. It is neither 1 1 nor onto. Okay, now let us go for the 14th one. Now let us go for the 14th one, that is f is in a function from R to R. F is in a function from R to R defined by f of x is equal to 1 0 minus 1. If x is greater than 0, if x is equal to 0, if x is lesser than 0, if x is lesser than 0. Okay. So now you can see that it is signum function. Clear? So we have to show that it is neither 1 1 nor onto. So for not 1 1, you just see, for not 1 1, x is greater than 0. That means I can take f of 1. F of 1 is what? 1. F of 2 is what? 1. Because whenever x is greater than 0, take x is equal to 1, greater than 0. Take x is equal to 2, greater than 0. What is your output? 1. Okay. So here f of 1 is equal to f of 2, but 1 is not equal to 2. Therefore it is not 1 1. Therefore it is not 1 1. See, okay, so I will clarify this as not onto and I will go for your doubts. Not onto. Okay, so for not onto, you just see range. In the range you have only 3 elements, 1 0 minus 1. In the range you have only 3 elements, 1 0 minus 1. These are the only 3 outputs. Okay. Whenever x is greater than 0, 1 is the output. Whenever x is equal to 0, 0 is the output. Whenever x is lesser than 0, minus 1 is the output. So only these 3 elements are your elements in the range. So write them. What is codomain? Here the codomain is equal to complete real number set. Complete real number set. Therefore range is not equal to codomain. Range is not equal to codomain. Therefore it is not onto. Therefore it is not onto. Okay. Clear? Therefore neither 1 1 nor onto. Clear? So Sanjeev is telling that sir, decimals do not comes in integer set. So see here, these decimals are of domain. So domain is real number set. Okay, domain is real number set. So that's why I can take 1.1 and 1.3 because x belongs to domain, that is R. So in the domain real number set, these elements are present, 1.1 and 1.3. So greatest integer of 1.1 is 1 and greatest integer of 1.3 is 1. Okay. So in the codomain you have 1 and 1. Clear? So codomain is complete real number set, but the range will be what? Only integer set. So now if you go on solving your greatest integer set, that is f of x is equal to greatest integer, in the 11th class you may have studied the graph, the range, the domain and everything. There you will learn the range of greatest integer set will be integer set. Okay. So but here see the codomain is real number set. Therefore codomain is not equal to range. Hence it is not onto. So I think Sanjeev got his doubt clear. And here also you can see 14th problem, very simple. It is signum function. It has only 3 outputs, 1, 0 and -1. But in the codomain you can see they have given complete real number set. This is the codomain. Okay, codomain is complete real number set. Therefore range is not equal to codomain. Therefore it is not onto. Okay. So I think all of you have understood this. So now with this, all your 5-mark problems of relations and functions chapter is over. So you go through this 15 problems for your 5-mark problems for the reduced syllabus of this year. So from this 14 or 15 problems you will get one problem. All are very simple. You can do them, no problem. Okay. So now we shall end this class here. So tomorrow at 10 AM or tomorrow at 11 AM, are you free? Tomorrow at 11 or 12 AM. If you say 11, I will take at 11. If you say at 10, I will take at 10. Because already we have lost one class today because of power cut problem. Otherwise, if you say at 8 AM, I will take at 8 AM only. No problem. At 8 AM, I think you will have no any other classes. So if you say yes, I will take at 8 AM only. So tomorrow from 7 to evening 7, you can tell any time from morning 7 to evening 7. Because today we have lost one class. So tomorrow I think I need to go with more classes. Clear? From morning 7 AM to evening 7 PM. You can tell any time. So best time will be 8 AM. Okay. So at 8 AM I will take one class. Clear? So I think at 8 AM you are not going to have any classes. Right? So at 8 AM I will take one class, that is of your differentiation chapter, which we were used to solve at 9 PM. I will take at 8 AM. Clear? So if I take 8 AM one class, no problem, I can engage it. So with 8 AM we can start our classes. Morning 8 AM and evening 9 PM there will be 2 classes tomorrow. Okay. Okay, let's see what happens tomorrow. And if there is any change in the time, I will put in your WhatsApp groups. There is any change in the time, I will put in WhatsApp groups so that you can go through that. Thank you everyone. Good night and take care. Thank you everyone. Good night and take care. Okay.